So this last one, I don't have time to do them all, but it's all about the first x squared, a squared, whatever it is. You never want to minus, and if possible, factor out as many uh, common numbers as you can. But at the very least, you never want to minus. You want to factor out a minus 1 in a lot of cases. I don't have time to do all of these, but I'll do a few. Often when you find a common number, for instance, 5 is common in each, but I don't want this minus in front of my whatever squared. So in this case, I'll factor a 5, minus 5, and that'll change the negative 5a squared to just a squared. It'll change the minus 5a to plus a. It'll change the plus 30 to minus 6. That's 1a, and plus 6. If I look closely, sorry, minus 6. If I look closely now, instead of this large numbers, I'm looking for a number that multiplies out to minus 6 and adds up to 1, which is clearly 3 and minus 2. And because there's no longer a number up here, I can just go straight to factoring. A plus 3, a minus 2. Makes it a lot easier when I get rid of that minus and that minus 5. They're all like that. So this has a minus 3 in common. If 3 is common with all of them, and I want to get rid of this minus. I'm left with a squared minus 5a plus 4. So I'm looking for something that multiplies out to positive 4 and adds up to minus 5. That's minus 4 and minus 1. So that becomes minus 3, a minus 4, a minus 1. Be aware that when we factor, you're finding the factorable numbers. When we do a quadratic function, we're finding the roots, which are opposite of these numbers. Here we can see minus 5 is what I want to get rid of in all of them. When I take out the minus 5, I get x squared minus 7x plus 12. So I'm looking for a number that multiplies out to positive 12 and adds up to minus 7. So we're talking minus 3 and minus 4. Note that it doesn't matter if it's a squared, y squared, whatever it is. As long as it's the same letter here, you can do it. So I get minus 5 in front, x minus 3, x minus 4. And I believe that's... Oh, then they want us to solve it. Okay. So remember that it's equaling 0. So if either of these brackets is 0, it will be true, and it's the opposite of these numbers. So minus 3 will make 0, and 2 will make 0. And sure enough, if you plug it back into the original equation, you'll see that the original is equal to 0. The solutions here are 4 and, what was this, minus 4 and minus 1? Yeah, that was supposed to be minus 1. So 4 and 1. Down here, the solutions are 3 and 4. The opposite of the factors. Here we can take the minus 2 out. We get w squared minus 2w, because we have to factor minus 2 out of all of them, minus 15. Looking for a number that multiplies out to minus 15 and adds up to minus 2. So it's 5 and 3, minus 5, w minus 5, and w plus 3. With the minus 2 in front, the minus 2 doesn't matter to the solution. The solution is 5, the opposite of that, and minus 3, the opposite of that. These are the roots that the quadratic function would kick out. These are the factors that factoring kicks out. Slightly different. Here we take a minus 4 out. We'll get k squared plus k minus 2. So we're looking for the factors of k plus 2 and k minus 1. Doesn't matter if there's the minus 4 in front. The solution is still minus 2 and 1. Over here, we factor out minus 1. We're left with k squared. All the symbols change as a result. Plus 7k plus 12. So in this case, we're looking at k plus 3 and k plus 4 with a minus 1 in front in case the teacher asks you for the equation. But the solution is still minus 3 and minus 4, the opposite of the factors. Okay. And they're all like that. I don't really have time to do them all. Some of them you won't be able to factor out perfectly. So for instance, here is 7. Um, I don't think that's factorable by 7. Let's see, 7 times. No, it's not. 7 times 8 is 54, but that doesn't have a solution. So we're just stuck with finding the multiplier of this and that. But that's quite a large number. Let's see if... So I don't believe this really has a solution. So you have to use the quadratic equation where A is 7, B is minus 51, and C is 54. And before you even do that, determine the discriminant B squared. So 51 squared minus 4 times that, because it might not be possible. But then you just have to solve it. And the quadratic will kick out the exact answers. This is similar. You cannot solve with the nothing factors out, but you can take out the minus. But you're left with 3n squared plus 4n minus 20. So you're looking for a number that adds up to, multiplies up to minus 60 and adds up to 4, and they're going to be very close together because that's small. So 15 and 4 doesn't work. 6 and 10. 6 and 10. Okay, so you're talking about minus 10 plus 6. No, and minus, no, let's see. Yeah. Plus 6 and, sorry, plus 10 and minus 6. And you have to group. You always want to get the minus out so that you're left with 5a squared minus 6, plus 16, everything changes, plus 3. So you're looking for a number that multiples out to 15, adds up to 16, so that's 15 and 1. But that's not the answer, because when it's got a number in front, you've got a group and slip and slide. So it would be a plus 15, a plus 1, and then when you put the 5 in front, it's 5a plus 1, a plus 1. So the answers are minus 1 and minus a fifth. So they're all similar. Let me just jump to the end because I don't have time. Yeah, they don't have anything in common. So it's just old school. I'm going to get rid of the minus 1s at the very least. Minus 1s. Yeah. They're all pretty much the same. They're just heavy work about getting rid of the minus. This one you don't do anything to. You're looking for a number that multiplies out to minus 42 and adds up to 1. So you're talking about something that's very close together, like 7 and 6. That's exactly 7 and 6, actually. B plus 7, B minus 6, and then you divide it by 2. So it's B plus 3 and 2B minus 2B plus 7 and B minus 1, I think.